Hello people, I've recently gotten a lot of requests on how to deploy a set of Docker containers on orchestrated Kubernetes clusters on the cloud. I'm going to be showing this kind of deployment using a streaming engine within a reverse proxy server into the cloud. So this demo will cover the aspects of cloud-native deployments, containerization, configuration management using tools like CloudFormation, observability with CloudWatch, also CI/CD through Git and Docker, and service mesh using Linkerd. So let's go. I hope this tutorial will help anyone deploy this kind of cluster to the public clouds and maybe even on-prem deployments. So since I've already developed the solution, this is hosted on GitHub, so I'll add the link for review. The main components of the GitHub repository are the Nginx reverse proxy, the Docker file, and the bash scripts that deploy YAML files. These specify the type of Kubernetes deployment on AWS's EKS, Elastic Kubernetes Service. The containers are available on Docker and ported into ECS, the Elastic Container Service. So these are able to integrate with third parties as well as expand within AWS services. The Docker Hub containers can be ported to any other container registry. So this makes multi-cloud and hybrid cloud development and deployment easier as well. So by the end of this video, we'll have a highly available fault-tolerant self-healing Kubernetes streaming server cluster, which is able to auto-scale and be provisioned for production level events in any region of the world and in any public cloud provider, not only AWS but Azure and Google cloud platform. The benefits of this deployment lie in its scalability, and it's also possible to specify resources like compute. So we're going to see this on the tutorial. So we'll be able to assign the desired capacity in terms of instance types, compute, and factors like that. So let's go, and hopefully this will help demystify some of these concepts and technologies. Now we're going to see the folder. So that is the folder with the YAML files and the deployment shell commands, scripts. In this command, we are pulling the Docker image for the streaming service into our local environment. This is using the docker pull command of a Dockerized application hosted in the Docker Hub. And that's it. Now we should have a image. Maybe we can reference it on the Rancher application, so you can see the addition in here. And we in future steps we'll be able to push this to the EKS service in AWS. In this step we're building the repository into the Docker image. We need to find the Docker file. This should be here. In this step, we're building service mesh injected into our control plane. We will be able to log into the dashboard and to also generate a Grafana dashboard. So we can see this here. And you can see all the metrics and monitoring of the cluster. We will review the code base of the Kubernetes deployment to make sure that it deploys successfully in the Asia Pacific region with multi-availability zone configuration. So you can see these flags on the launch deployment script. I'm also exposing port 1935 for RTMP, and this is based on the Docker image. So it will be pulling the image and deploying it to the EKS service. You can see the configuration for the cluster and the YAML file that's configuring the regions and the instance types, meaning the compute capacity. In this instance, I am assigning 3 instances of medium capacity, meaning that if one fails, the other one will come in, and if one of these 3 fails, the cluster self-heals and will always keep 3 instances on the cluster. This is the engine deployment YAML, and is a ECR image. So this is pulling from the Elastic Container Registry private registry. So we're going to go to the terminal, and here we're on the folder already, and using the bash command line, we're going to deploy the application. This already contains the EKS CTL application already scripted, so it's going to do all these functions just with one command, and this should start the deployment process to the Asia Pacific region. 3 instances, all load balanced throughout the region for high availability and fault tolerance. The Kubernetes cluster also adds self-healing properties, which I will show on a later step.
In terms of cloud configuration management, you can see that the cluster is relying heavily on CloudFormation to create the stacks of technologies that conform the application cluster. This also I can show at a later stage, just because it's a major process which automates all the configuration parameters required to run this orchestrated containerized application. It handles the creation of load balancers of the VPC. It generates a new virtual private cloud. Generates all the necessary components that make up the whole of the Kubernetes cluster. And this process takes about 20 to 25 minutes on this kind of deployment. So we have to let it run, and most likely I'll just fast forward this part and we'll see each other in a few minutes. So this is it. Now we have the load balanced Kubernetes cluster, and we should be able to see it on the EKS dashboard. We have already deployed our cluster to the EKS service, and we can see the resulting metadata on the dashboard. This has 3 instances of T2 Medium deployed in the Asia Pacific region. So it's load balancing and between these availability zones, adding to the high availability of the solution. You can also see the health and some of the details on the deployment, the API endpoint. Sometimes you can also configure some of the settings, and the main resulting endpoint in this part of the video is to interact with the resulting a record on the load balance. This is listening to port 1935, which is the streaming port for RTMP. So we're going to send a stream to this record and see if it works. So I already have configured this RTMP endpoint using the DNS and sending traffic to port 1935. So let's see if this works. Let's see the logs and load a video I titled Rising Sun. It's one of my own creations. So let's start streaming and see if this works. So this is really fast. The live streaming has been successful. So this is sending traffic to the Kubernetes cluster on the elastic load balanced endpoint through port 1935. This is highly available and fault tolerant. If any of the instances run out of capacity, the defined capacity, the desired capacity is always 3 instances. So if one fails or something happens, it's going to self-heal, and the traffic should keep going. So this is the streaming server use case for Kubernetes cluster, and I hope this helps you understand more how to deploy these types of solutions.